Let us discuss some of the MCQs which are based on group 13 and group 14 elements of the P block group. So question number 1 is, name the type of the structure of the silicate in which one oxygen atom of SiO4 4- is shared. So it is something, a particular structure which is ice-line type. This is oxygen, silicon. So these are the silicate units which are shared and we have a single oxygen in between. So this is ice-line structure, which is also called as the pyrosilicate type, and that's why our option is D. Question number 2 is the strongest Lewis acid amongst the particular boron halides. Now if I talk about the option BBr3, BCl3, Bi3 and Bf3. According to the electronegativity wise, we are expecting the boron is attached to the 3-fluorine and fluorine is most electronegative. So it will withdraw the electron from boron and it will make this boron more electron deficient, and because of this reason it will take this particular electrons easily. So we are expecting the answer as strongest Lewis acid as Bf3, but actual answer is Bi3 is the strongest, then BBr3, then it's BCl3 and finally Bf3. This anomalous behavior related to Bf3 is because of the fluorine is back donating its electron to the boron. Now fluorine is having its electron in 2p orbital and boron is also having the 2p orbital empty. So since there is back donation in the same energy level, this back donation becomes easy, and therefore because of this back donation there is a partial pi bond character between the boron and fluorine, which makes the Bf3 stronger in nature. Hence we are expecting the answer now Bi3. So our option is C. Question number 3 is, the graphite is a good conductor of electricity. Its electrical conductivity is due to the following facts. Option A, it is an allotrope of carbon. Though it is allotrope of carbon, carbon has different allotropes like diamond and the graphite, but diamond is the particular allotrope which is bad conductor of electricity. So that can't be the option. Option B, it has carbon atoms arranged in the large packs of the rings of strongly bound the carbon atoms. Again, for conductivity, this cannot be the reason. Option C, it has a carbon which is sp2 hybridized. Yes, when the carbon is sp2 hybridized, you have carbon in the excited state carrying 4 electrons. Now this is sp2 hybridized, so one of the electron is free on each carbon, and since this electron is free, it is available for the conduction of electricity, and hence our option is option C, that is it is the carbon atom are sp2 hybridized, keeping one of the electron free for the conduction of electricity. Question number 4 is, the borax is used as a cleansing agent because of the dissolving in water. It gives alkaline solution, acidic solution, bleaching solution or amphoteric solution. First of all, borax is Na2B4O7 on dissolution in water forms NaOH and the acid H3BO3. H3BO3 is the weak acid and NaOH is a strong base, which makes the overall solution alkaline in nature. Hence our option is A. Question number 5. Which of the following is not hydrolyzed easily? When I'm talking about the halides of that particular group 14, this is carbon, silicon, germanium and tin. In this case, when I'm talking about hydrolysis, let us take example of silicon. When you have this tetrahalide of the silicon, here when it is hydrolyzed, it can be, the chlorine can be replaced by the OH easily. This is something the lone pair exception of the water by the silicon. This is only possible for the silicon because of its empty d orbital. That means for the hydrolysis, the central element should have the empty d orbital so that it can accept the lone pair from the ligand water. In this case, carbon is the only element which is having configuration 2s2 2p4 is not having the d orbital in its valence shell, and because of the absence of that d orbital, it's not possible to take up this lone pair of electron from the oxygen. Hence, hydrolysis is not easily possible for CCl4. Question number 6 is, for which element the inertness of the electron pair will not be observed? In case of inertness of the electron pair, what is the meaning of this? In case of the p block element, it has been found that the higher element, that is the last elements of each group, they generally have d and f electron in their inner shells. And since they have d and f electron in the inner shell, they get poor shielding effect. This poor shielding effect, let's say they have a configuration, let's say I'm talking about the bismuth, which is the element of group 15. It has the configuration, outer shell configuration, as 6s2, 6p3. In the inner shell, it has the electrons like 4f and 5d. These are giving poor shielding effect, and as they give the poor shielding effect, the ground state of the bismuth, which is having 3 electrons unpaired, only participate in the bonding. If it wants this particular 6s electron to participate in bonding, it has to be excited to its d orbital. But this kind of concept is not possible for the bismuth, because this inner electron, that is ns electron, has a strong attraction towards nucleus because of the poor shielding effect, and this excitation becomes difficult. So bismuth shows only lower oxidation state +3 and not the +5. This particular concept, that is higher element, shows the lower oxidation state. It has been seen with the p block element. Tin, lead and indium, they are p block element, but Fe is a d block element. Hence, the one which is not showing this kind of inertness is option B, that is Fe. Question number 7, in which of the following molecule is hydrogen bridge is present? Now, in case of water, we have simple bend structure. There is no bridging bond is present. Inorganic benzene, we have BN, BN, BN. So it is kind of like inorganic benzene. Then here also we have all sigma and pi bonds. So there is no bridge bond in this. In case of diborane, we have each borane bonded to the hydrogen by a simple bonding, but there is a bridge bond between the two boron and the hydrogen. So here two bridge bond structure, or also called as banana bond structures, are present in the diborane. Hence our option is C. Question number 8 is, the stability of +1 oxidation state increases in the following sequence. When I'm talking about oxidation state, that is +1, here we have elements aluminium, gallium, indium and thallium. In this case, when I'm talking about down the group, the order is aluminium, gallium, indium and thallium. This is all elements belongs to group 13, which have a common oxidation state of +1 and +3. But as we discussed previous, that as you go down the group, the inert pair effect makes it difficult to exist in higher oxidation state. That's why +1 oxidation state down the group goes on increasing. Hence the thallium is more stable in +1, then indium, gallium and the lowest is aluminium. Hence our option is A. Question number 8 is, the darkening of the surface painted with the white lead is due to. Now when I'm talking about when you have a lead, if you coat it with, let's say, H2S, the lead has affinity for the sulfur and it forms the PBS, which is black precipitate. And since it forms this black precipitate, the surface of the lead turns to the dark, and hence our option is H2S. Question number 10 is, a mixture of boron trichloride, that is BCl3, it's subjected, and the hydrogen, it's subjected to the silent electric discharge. They are saying there is compound A and HCl is formed. Now, if I talk about this particular reaction, obviously we are expecting hydrogen will react with boron as well as hydrogen will react with chlorine. With the chlorine, it's forming HCl, so definitely boron has valency 3, so we are expecting the compound BH3. But BH3 is the electron deficient compound, never exists in the monomeric form. It always exists in its dimeric form. So we have a compound B2H6. That is, B2H6 will be option A. Now this A, when it is mixed with the ammonia, we are expecting the compound B. B2H6, when it is allowed to react with ammonia in 1:2 ratio, we are getting the inorganic benzene, that is B3N3H6, or called as borazine. So our compound B is borazine. They have asked us the formula of the compound B. So it's B3N3H6, hence our option is C. Question number 11 is the borax bead test is a compound is formed. What kind of compound is formed in the borax bead test? First of all, what is borax bead test? It's generally performed with the borax on the platinum wire. So we take the borax on the platinum wire. Borax is Na2B4O7 with the 10 water molecules. When you heat this particular compound, it loses this 10 water molecule to form Na2B4O7. This on further heating decomposes to sodium metaborate plus B2O3. This sodium metaborate is a transparent bead called as borax bead. This can be used for the detection of different color radicals. For example, if I am detecting the cobalt, let's say cobalt sulfate is there. It will decompose to give cobalt oxide, and let's say sulfur trioxide is liberated. This cobalt oxide reacts with this B2O3 and it will form its own metaborate, cobalt metaborate, which is blue in color, which is one of the confirmation of presence of the cobalt in the salt. So the kind of salt which we get a color and we detect the element is a metaborate salt. Hence our option is B. Question number 12 is, which of the following is the most basic oxide? Options given are aluminium, antimony, bismuth and selenium. Now when I'm talking about these particular elements, in this case, first in the group 13 we have aluminium, then we have Sb antimony, and bismuth we have in group 15. So antimony and bismuth we have in group 15, and in group 16 we have selenium. Now they have asked us the most basic oxides amongst this. So in basic oxide we need a more metallic property. When I'm talking about down the group, its metallic property goes on increasing. So bismuth is present in the last period compared to the other element. So bismuth is having more metallic character. Since it has more metallic character, its oxide will be more basic in nature. One more reason is this is one of the basic oxide because its reactivity towards the acid is more rapid and more reactive towards the acid. Hence our option is option C. Question number 13 is, which of the following is the electron deficient compound? If I talk about the boron, this is a dimeric form of the boron, that is borane BH3, in which the boron contains 3 electrons in the outermost shell and hydrogen is sharing 1 electron with the boron. So after formation of this compound also, the outermost shell of the boron is incomplete, so it is electron deficient compound. But when I'm talking about the carbon contains 4 electrons in the outermost shell sharing 4 electrons with the hydrogen. So definitely this particular compound is having a complete octet. PH3, if I talk about it, phosphorus contains 5 electrons in the outermost shell. Out of that, it's sharing 3 electrons with the 3 hydrogen. So definitely its octet is complete. And finally we have selenium hydride, that is silanes. Silicon also contains 4 electrons in the outermost shell, sharing 4 electrons with the hydrogen. So its octet is also complete. So the electron deficient compound is option A. Question number 14 is, X reacts with aqueous NaOH. Solution: to form compound Y and H2. This particular compound Y is heated at 323 to 333 Kelvin, and on passing through the carbon dioxide, we are getting formation of compound Z along with the formation of Na2CO3. Now this Z compound, they are saying further heated at 1200 degrees Celsius so as to get the compound Al2O3. So we have to find out what are the X, Y and Z. Definitely, if you're heating Z compound to get Al2O3, this is losing water molecule to get Al2O3, and this is nothing but the property of aluminium hydroxide. Aluminium hydroxide, when on heated, it gives you formation of Al2O3. That means my option Z has to be yellowish thrice. So such we have option B or option D. Now when I'm talking about how to obtain this yellowish thrice with the Na2CO3, definitely this is a kind of like a base process where we get the NaAlO2, sodium meta-aluminate, which on reaction with carbon dioxide gives you yellowish thrice and zinc carbonate. So definitely our starting element has to be aluminium. So X is aluminium, Y is sodium meta-aluminate, which is on further heating gives you yellowish thrice. So our option is D. Question number 15 is, the gas A is bubbled through the select lime. Select lime is calcium hydroxide. So we are getting a white precipitate. Definitely, if you are getting the white precipitate by passing certain gas through the calcium hydroxide, definitely this gas has to be carbon dioxide. Because when carbon dioxide is allowed to react with select lime, we get formation of calcium carbonate plus water. Calcium carbonate is insoluble in water. That's why you're getting a milky solution or a white precipitate in this. What they are saying further, on prolonged bubbling through the solution, the precipitate dissolves. That means if I pass more carbon dioxide through this solution, this will become soluble. This is because the calcium carbonate reacts with more carbon dioxide and it forms calcium hydrogen carbonate, which is water soluble compound. So first you are getting the formation of water insoluble compound, that is giving white precipitate, and then you are getting formation of white soluble compound with the liberation of carbon dioxide gas. They are saying the white precipitate reappears with the evaluation of gas B. So gas B is also carbon dioxide only. Hence our option is D. Let us discuss some of the MCQs which are based on now group 15 and 16. That's nitrogen and the oxygen family. Question number 1. A basicity of pyrophosphorus acid we have to find. When I'm talking about pyrophosphorus acid, which is something obtained by the pyrolysis of orthophosphorus acid. So its structure is P double bond O, OH, H, having POP linkage. Again same P double bond O, H, OH. Now here we have two acidic protons which are attached to the oxygen. Hence it can react with the two bases. So basicity of this acid is 2. Hence our option is A. Question number 2 is the ammonia on the reaction with excess of chlorine. So NH3 on reaction with excess of chlorine, we get a compound NCl3 which is explosive in nature along with the liberation of HCl. So this particular reaction is giving us NCl3 and HCl. So our option is option A. Question number 3, the number of PO bonds in the P4O10 we have to find 16, 12, 8 and 4. These are the options given. When I'm talking about oxides and the oxy acids, always remember P is having one of the bond as P double bond O. Now there are 4 P, so I'm writing 4 P. So double bond O, double bond O. Each PP linkage will be there through the oxygen. So this is through oxygen. We have this also in between and this also in between. So if I count over here right now, how many PO linkage are there? You have to find the PO bonds in the P4O10 is, now there are 1, 2, 3, 4, 5 and 6. There are 6 linkage. But in 6 linkage if you will find, there is 2 PO bonds. So 6 linkage and each containing 2 PO bond, that means that will be having 12 PO bonds. Plus we also have P double bond O bonds. So such we have 4. So total 16 PO bonds in the P4O10 molecule. Question number 4 is sulfuric acid reacts with the PCl5 to give. When I'm talking about structure of sulfuric acid, it's OH, SOH, double bond O. Now this, when it is allowed to react with PCl5, which is a chlorinating agent, replaces the nucleophile OH by Cl. So we'll get Cl, S double bond O and Cl. This is nothing but SO2Cl2, which is sulfuryl chloride. Hence our option is option C. Question number 5 is, which of the following is not correct? The white phosphorus, that is P4. Let us first draw the structure of the white phosphorus. We have 4 phosphorus which are attached, arranged in a tetrahedral fashion. Each phosphorus is attached to the another phosphorus by the single bond, and each of them will carry the lone pair. Now 6 pp single bonds are there. 1, 2, 3, 4, 5 and 6. 4 pp bond, obviously if it has 6, the 4 is not possible. So we got our option, that is B. 4 lone pair on the electrons, yes we have, and the PPP bond, this is 60 degree. So definitely which is not correct is option B, 4 pp single bonds. Question number 6, by which of the following process the pure nitrogen gas can be prepared? First is a dichromate heating, ammonium chloride NaNO2 heating, ammonia and NaNO2 heating, and finally we have N2O copper heating. In this case, if you go through the methods of preparation of the nitrogen gas, we have an option in the laboratory method, ammonium chloride and NaNO2. When they are allowed to react with each other, we first get formation of ammonium nitrate and NaCl. This ammonium nitrate, on further heating, we get formation of the N2 gas in the pure state. Hence, our option is option B. Question number 7 is the order of stability of metal oxides we have to find. Now when I'm talking about order of stability, obviously stability is something which is dependent on the lattice energy, and lattice energy, which is something dependent on the charge and the size of the ions. Now in this case we have a chromium, aluminium, iron and magnesium. Now if I talk about this, most of these elements like Fe and chromium exhibit different oxidation state. For aluminium it's +3 and magnesium is +2. So lowest charge is on magnesium. So magnesium oxide will be the most stable amongst them. So in this case we have option B as well as we have option C. Now when I'm talking about the oxides which are given here, the Fe is present in its +3 state. Chromium is also present in its +3 state, and aluminium is also present in +3 state. But when I'm talking about their sizes, the aluminium is having the smallest size, and the charges of all these are fixed. Aluminium, obviously its atomic number is 13. Chromium is having atomic number of 24, and Fe is having 26. So in this case, if I talk, aluminium oxide will be more stable, then chromium, and then Fe, as the aluminium has the smallest size and this particular option. So if I want the magnesium to be more stable, and after that I want aluminium to be more stable, hence our option should be option B. Magnesium oxide has to be more stable, then aluminium, chromium, and the last one is Fe oxide. Question number 8 is the correct order of acidic strength we have to find. Now different oxides are given to us. Now in this case, if I talk about the option A, we have a chlorine which is to the extreme right hand side of the periodic table. Then we have a sulfur, and then we have a phosphorus. Now if you go left to right in the periodic table, non-metallic character increases and non-metallic oxides are acidic in nature. So we are expecting the chlorine oxide has to be more acidic, then sulfur, and then phosphorus. Here only we got our option, that is option A is correct strength of the acidic. We can also confirm the rest of the thing when I'm talking about carbon, nitrogen and sulfur. Now amongst them, extreme right hand side is a sulfur, then we have a nitrogen, and then we have a carbon. So in acidic strength wise, the sulfur trioxide has to be more acidic. That's not the correct answer given over here. When I'm talking about now sodium, magnesium and aluminium. When I'm talking about this particular order, sodium, magnesium and aluminium, since they're metallic oxide, we are expecting their oxides has to be basic in nature. So in this order, if I talk about it, sodium has to be more, then magnesium and then aluminium. This is the order correct But if they would have asked us about the basic strength, but this is not a basic strength, this is acidic strength, the order should be reverse, which is not given, hence this is a wrong option. Again, same thing for the option D. If I talk about the order which is given over here, this is absolutely right when I'm talking about the basic strength, but not correct for the acidic strength. Hence, our option is option A. Question number 9 is the reaction of the element P4 with the aqueous NaOH. When you allow P4 to react with NaOH, this is in aqueous media, the P4 itself undergoes the disproportionation reaction. That means some of the phosphorus will undergo oxidation and some of them will undergo reduction. When it is reduced, it gives formation of PH3, and when it is oxidized, it gives formation of NaH2PO2. And hence, our option is option A. Question number 10 is, which of the following compounds are the most acidic in nature? Now, when I'm talking about arsenic, phosphorus, antimony, bismuth, they all belongs to the same group, that is group 15. But the order in the group is, first we have phosphorus, then we have arsenic, then we have antimony, and then we have bismuth. Now, when I'm talking about arsenic the phosphorus is non-metal, they are metalloids, and finally bismuth is metal. We generally say non-metal oxides are acidic and metallic are basic. So down the group, basic character increases, acidic character decreases. So the most acidic oxide has to be P2O5. Hence, for the question 10, option is B. Question number 11 is, which of the following oxide of nitrogen is anhydride of the nitrous acid? Now, when I'm talking about nitrous acid, it is HNO2. Anhydride is something which is obtained by the loss of water molecule. Now, definitely this is cannot lose, one single molecule cannot lose a water molecule. So we'll take 2 molecules of nitrous acid. From this we'll remove the H2O. So this is H2O removed, and from 4 oxygen, 1 oxygen is removed. So what is left behind is N2O3. So N2O3, that's our option B, is the anhydride of the nitrous acid. Question number 12 is, KMnO4 acts like oxidizing agent in acidic media. To provide the acidic medium, H2SO4 is used instead of the HCl. This is because. Now let us discuss about the KMnO4. KMnO4, as I said, this is usually act as an oxidizing agent, and for this we need H2SO4. This is itself is an oxidizing agent, so it is itself undergoing the reduction reaction, and since it is undergoing the reduction reaction, it will gain some electrons, and we are expecting whatever electrons it is gaining, it is being gained from the other reducing agent. So option A, H2SO4 is the strongest acid than the HCl. HCl is oxidized by the KMnO4 to Cl2. H2SO4 is a dibasic acid. Rate is faster in the presence of H2SO4, or only H2SO4 is completely ionized. In this case, whatever acid I'm using over here, it should not participate in the reaction. But what happens is, when you take HCl, it itself gets oxidized by the KMnO4 to the chlorine. So HCl itself become chlorine. But this is not that possible in case of H2SO4, because the potential required is comparatively higher. So we can use H2SO4 as an acidic media over here, not HCl, because HCl here itself participate in the reaction when it is allowed to react with KMnO4, giving liberation of chlorine. Hence our option is option B. Question number 13 is, which of the following has the highest proton affinity? If it is having proton affinity, that means it reacts with the proton faster, they themselves are bases. If you find all these elements are given, they are from group 15. So in group 15 we have nitrogen first, then phosphorus, then arsenic, and then we have antimony. Down the group, electronegativity goes on decreasing. So nitrogen is the most electronegative element, and it can act as a base more easily compared to the others. Hence, highest proton affinity with the hydride of nitrogen. Hence, our option is ammonia. Option C. Question number 14 is, the acidity of hydrides of oxygen, sulfur, selenium and tellurium varies in the particular order. When I'm talking about acidic nature, they are losing their H+. We have oxygen, sulfur, selenium and tellurium. Down the group, if I talk about it, size of the atom goes on increasing. the bond becomes weaker and hence the hydride can be broken easily. So tellurium hydride can be broken easily. Since it is broken easily, it can give you H plus easily. So highest acidic strength with the tellurium, then with the selenium, then with the sulfur, and then with the oxygen. Hence our option is option B. Question number 15 is the decreasing order of boiling point of the following hydrides we have to find. Now when I'm talking about these are the elements, first of all we have nitrogen which belongs to group 15, phosphorus also belongs to the same, then arsenic, then antimony, and then we have water which is oxygen hydride from the group 16. We have to talk about the boiling point range. Now if I talk about electronegativity wise, oxygen is more electronegative than the nitrogen, have more hydrogen bonding tendency. So amongst all, if I talk about it, the water should have the highest boiling point ever. So highest boiling for the compound E has to be there. Then amongst these, nitrogen hydride form the hydrogen bonding. But rest of the hydride has a dipole-dipole interaction, and dipole-dipole interaction down the group goes on increasing as the size of atom increases. So highest strength is for Sb. So after the compound water we have Sb, that's our compound D. Then in the remaining three, nitrogen has a hydrogen bonding, so we'll have a compound of nitrogen later on, and between these two arsenic has a bigger size, so more size have a more interaction, so arsenic, which is option C, and then the least is for the B, that is phosphorus. So E, D, A, C, B, and hence our option is A. Question number 16 is bleaching action of SO2 is due to its oxidizing property, acidic property, basic property, or reducing property. When I'm talking about SO2, which acts as a bleaching agent in presence of the water. In presence of water, it gives formation of H2SO4 with the liberation of the nascent hydrogen. So all its bleaching action is because of its reducing property. Hence our option is option D. Question number 17 is a colorless gas with the smell of rotten fish. H2S is having rotten egg smell. PH3 is a rotten fish. SO2 is a pungent odor. So our option is option B, which is PH3. Question number 18 is which of the following oxide of the nitrogen is solid in nature? NO2 is a gas, N2O is a gas, N2O3 it's solid, and when I talk about N2O5, which is also gas, or in the lowest form it is in the liquid form. Since the question is which is the solid amongst them, our option is option C. Pi3 on hydrolysis gives what kind of acids they are asking. When I'm talking about Pi3, if you carry out hydrolysis of this, we get formation of H3PO3 and we get formation of HI. Now H3PO3, it is something P double bond we have one OH, another OH and H. We have two acidic proton over here, hence this is dibasic acid. This has only one H plus, so this is monobasic. So we get combination of one dibasic acid and one monobasic acid. So we are having option A, which is monobasic acid and dibasic acid. So option A. Question number 20 is which one of the following acid possesses the oxidizing, reducing and a complex forming property? Now out of these two, let us talk about the different oxidation states. In nitrogen, HNO3, the nitrogen is present in +5 oxidation state. +5 is the highest oxidation state for the group 15. So beyond it, it is not possible. So this can be reduced, but it cannot be oxidized. So this is good oxidizing agent, itself undergo reduction, but it is not good reducing agent. And you need an acid which acts like oxidizing as well as reducing agent. So this is not an option. In chlorine, Cl minus, this is the lowest oxidation state which is possible for the chlorine. So this can be oxidized further. So it's good. This is itself is oxidized, so it's good reducing agent, but it cannot act like an oxidizing agent. Sulfur, it's +6, highest oxidation state over here. So definitely it is also good oxidizing agent, but not a reducing agent. But in nitrous acid, if I talk, this is oxygen, it's -4 and this is +1, so it is +3 oxidation state. In case of nitrogen, which belongs to the group 15, we have a lowest oxidation state -3, +3 and +5. Since nitrogen is right now present in +3 oxidation state, it can be oxidized to +5 or also reduced to -3. So both the things are possible for the nitrogen in this oxidation state. As well as if I allow this to react with the compounds like benzene having NH2 group, that is aniline, if I allow this to compound react with the nitrous acid, we get formation of the diazonium complex. And this kind of diazonium complex, that is complex formations, are possible. Hence our option is D. Question number 21 is, which of the following is not correct? In the first option, they have given the oxygen is passed through the silent discharge, giving ozone. But here they have written this is exothermic reaction, but this is actually the endothermic reaction. To break oxygen, the energy is required. So that's the wrong. Hence option A is the not correct option. But let us check other option also. Ozone undergoes the addition reaction with unsaturated compound. Yes, we know that when you talk about alkenes, ozonolysis is possible, converting them into corresponding aldehyde or ketone depending on what kind of the unsaturated compound you have taken. Sodium thiosulfate reacts with, sodium thiosulfate is Na2S2O3. When it is allowed to react with iodine, yes, we get the formation of sodium tetrathionate and sodium iodide. Ozone oxidizes lead sulfide to the lead sulfate. Ozone acts as an oxidizing agent. So lead sulfide can be converted into lead sulfate by using ozone. Hence, which is not correct is option A. Let's discuss some of the MCQs now on group 17 and group 18, that is halogen family and the noble gases. Question number 22 is the least volatile hydrogen halide is. Now when I'm talking about all the halogens, we have fluorine, then chlorine, then bromine and then iodine. They form their corresponding hydrides. Now in the case of HF, it has the hydrogen bonding with each other. Therefore, this is the one which is having highest boiling point. Amongst the three remaining, down the group, as the size of the atom goes on increasing, the dipole-dipole interaction increases and makes the boiling point higher. So the one which is having the lowest boiling point is HCl, which is existing in the nature in its vapor form. Hence, the most volatile one will be the HCl. Now, since they have asked us the least volatile hydrogen halide is, the least hydrogen halide volatile will be HF. So our option is A. In question 23, the geometry of XeOF2 is asked. Now in case of XeOF2, to find out the geometry, first of all, find out the number of hybrid orbitals. To find out number of hybrid orbitals, we have formula half into number of valence electrons in the central atom plus number of monovalent atoms attached to it plus whatever is the charge on that cation is there, okay, minus the charge on cation and plus the charge on anion. Now when I'm talking about the central element is a xenon. Xenon contains 8 electrons in its outermost shell. It's a noble gas. It's a group 18 element. Plus oxygen and fluorine. So fluorine is a monovalent. 2 fluorine are there. I'm adding 2. This is a neutral molecule. So it's not cation, it's not anion. So charges on cation and anion are 0. So this is 10 divided by 2. We get a 5. Though we have 5 hybrid orbitals, but the atoms attached to the xenon are only 3. So this is something sp3 dehybridization with 2 lone pair. Generally, when we have sp3 dehybridization, we have a trigonal bipyramidal structure with 2 lone pair which is distorted to T-shaped. Hence, our option is B, that's a T-shaped molecule. Question number 24 is the correct order of the acidity we have to find. We have HClO, we have HClO2, we have HClO3 and we have HClO4. In this case, we have +1, +3, +5 and +7 oxidation state for the different acids. The acidic strength will go on increasing with increase in the oxidation state. Hence, when I talk about the strongest acid is HClO4. So our option is option A. Question number 25 is the fluorine reacts with the water to give. When I'm talking about the fluorine, it reacts with water under the cold as well as hot condition. When it reacts with water under cold condition, we get formation of HF with the liberation of oxygen gas, while under hot condition, we get formation of HF with the liberation of ozone. So products are HF, O2 as well as O3. Hence our option is D. Question number 26 is which of the following halogen does not exhibit the positive oxidation state? Now when I'm talking about the positive oxidation state is not exhibited, that is fluorine. There are reasons. First of all, it has small size, high ionization enthalpy and highest electronegativity. Hence, it is option D. It cannot exhibit the positive oxidation state. It can exhibit only negative oxidation state, and that is also -1. One gas is bleaching the color of the flowers by the reduction and other gas which is by oxidation. Which are these gases present? When I'm talking about SO2 acts as the bleaching agent because of the formation of H2SO4 with the nascent hydrogen. So SO2 acts because of reduction. While the chlorine, when it reacts with water, we get formation of HCl and HClO. This HClO decomposes further to give nascent oxygen. So SO2 gives the bleaching because of reduction, while the chlorine gives the bleaching because of oxidation. Hence our option is option A. Question number 29 is which of the following is the pseudohalides? It is something they behave like halogen, but they are not they actually halogen. Our option is option A, cyanide. In the pseudohalides, we have other options like CN- or cyanates we have thiocyanates. These are the different pseudohalides available.